Hello, my name is Andrew Bobal, and today we're going to talk about fractions. First of all, let's get a basic definition of a fraction. A fraction is a part of a whole. Let me show you an instance. Here, I have a whole circle. This circle represents 1. Now, if I take this circle and split it up into parts, in this case, I'm going to split it up into 3 parts. This fraction is now broken up into thirds. Let's look at the fraction 1/3. Every fraction has 2 separate parts to it. It has a number on the top, and it also has a number on the bottom. The number on the top is called the numerator. And the number on the bottom is called the denominator. Let's look at some fractions around us. Here's our first example of a fraction. As you can see, we have a whole block of cubes. Let's see how many cubes there are. There are 1, 2, 3, 4, 5, 6 cubes. In this case, our denominator would be 6. If we're referring to the pink cubes, 2 out of the 6 cubes are pink. So our fraction to represent the pink cubes would be 2/6. We could also talk about the green cubes and say our fraction to represent the green cubes is 4/6 because there are 4 green cubes and 6 total cubes. Now let's look at these counters. Here, let's see how many counters we have so we can identify our denominator. We have 1, 2, 3, 4, 5, 6, 7 counters. So our denominator would be 7. Now when we're talking about these counters, let's see if we can figure out what fraction represents the red counters. Count the red counters. We have 1, 2, 3, 4 red counters. So our fraction to represent the red counters would be 4. And what was our denominator? That's right, 7. So our fraction to represent our red counters would be 4/7. Now on the opposite end, we have 3 yellow counters. So our fraction to represent the yellow counters would be 3/7. Very good. Now, let's talk a little bit about adding fractions. Here, we have 2/8, 1, 2, plus 3/8, 1, 2, 3. Now we're lucky enough to have our denominator be the same. In this case, our denominator is in eighths. So if we look at our equation, it would be 2/8 plus 3/8. And because we're still talking about eighths, 2/8 plus 3/8 would be 5/8. Very good. In the last example, we talked about adding fractions. Here, we're going to subtract fractions. Let's count how many twelfths we have. 1, 2, 3, 4, 5, 6, 7 twelfths. Let's write 7 twelfths. 7 twelfths. Now to that 7 twelfths, let's take away 3 twelfths. 1, 2, 3 twelfths. So we're going to subtract 3 twelfths. Let's see how much we have left. We still have 1, 2, 3, 4 twelfths. That's right, 4 twelfths. Because 7 minus 3 is 4, and we're still talking about twelfths. Again, our denominator stays the same. Now, we've looked at what a fraction is and how to identify a fraction. Now let's look at simple addition of fractions. We've talked about when the denominator is the same, but what if the denominator is not the same? What if we have 2/4 plus 3/8? Now, we can't add fourths and eighths. So we need to make our denominator the same. We can make a 4 into an 8 by multiplying by 2. Whatever we do to the bottom, we must remember to do to the top. In this case, your 2/4 is going to become 4/8. Because 2 times 2 is 4, and 4 times 2 is 8. 4/8 plus 3/8 equals 7/8. So in this case, 2/4 plus 3/8 equals 7/8. You need to remember that no matter what, whether you're comparing fractions, adding fractions, or subtracting fractions, your denominator needs to be the same. Now, sometimes when you're adding fractions, your denominator is not the same. In this case, we have both eighths and fourths. So in order to add these fractions together, we need to make the denominator the same. Let's think. Can we make a 4 into an 8? That's right, we can. We're going to make a 4 into an 8 by multiplying it by 2. When you multiply your fraction, make sure you're doing the same to the numerator and the denominator. Your fraction now becomes 2/8 plus our original 2/8. So 2/8 plus 1/4 gives us 4/8. We were able to make 1/4 into 2/8 by multiplying by 2. Let's look at a different example. Here we have both tenths and fifths. So let's see, how many tenths do we have? We have 3 tenths. So 3 tenths. And to that 3 tenths, we're going to add 2 fifths. Now here, our denominator is not the same. So again, we need to do something to our 2 fifths in order to make it into tenths. That's right, we can multiply by 2. Again, make sure you do the same thing to the numerator and the denominator. Your 3 tenths stays the same. We're going to add, let's see, 2 times 2 is 4, and 5 times 2 is 10. So 3 tenths plus 4 tenths is 7 tenths. This is also the answer to 3 tenths plus 2 fifths, 7 tenths. The most important thing to remember is to make your denominator the same. Now our same rule of keeping our denominator the same goes along with the idea of also we are comparing fractions. Here we're looking at 1, 2, 3, 4, 5 eighths. And we're going to compare that fraction to 1/4. Now you might be saying, of course we can see that 5 eighths is bigger than 1/4 because we have fraction tiles right here. And you can see that 5 eighths is much longer than 1/4. But what if there aren't fraction tiles? Let's talk about comparing fractions. When you're comparing fractions, you're using words like greater than, less than, and equal to. Let's take a look at an example. We were asked to compare 1/4 to 5 eighths. Now here in this instance, your denominator is not the same. When we saw this with fraction tiles, it was very easy to compare because you could see that your 5 eighths had a greater distance than your 1/4. If you don't have fraction tiles though, you need to remember your key idea. Make your denominators the same. Let's change your 4 into an 8 by multiplying by 2. Remember, whatever you do to the bottom, you must also do to the top. This fraction becomes 2/8. Now ask yourself, which one's bigger? 2/8 or 5/8? That's right, 5/8 is greater than 2/8. In this case, we would say from your original number sentence that 1/4 is less than 5/8. Remember your rule, keep your denominators the same. You guys have done a great job with the beginning of fractions. Now keep up all the hard work and you'll have fractions down, no problem.